He's just completed a source code review, a web application. I have a question out to you guys. If he's just finished that source code review and he has the results, what's he going to do with that, or how's that going to help him with the next release of that application? I want a real answer. I don't want a theoretical answer. It's not?
Not unless it's communicated back.
It's not because it's communicated back. Anything? Okay, what's a theoretical answer? What's a best practice answer? Okay, that's a little too theoretical. Next version won't be perfect.
Where'd you redirect the output?
Redirect the output?
Yeah, where'd you redirect it?
Oh, yeah, exactly. So there are a couple things that you could do, right? Like one thing you see a lot is remediation testing. We look back at our source code notes or review notes from the previous release, and we look at this release and say, have they fixed these issues, right? That's something that we can do. But a lot of what we gain by doing that source code review is lost, essentially. That comprehension of the application and understanding of the design, that's lost. And that's what I'm going to talk to you guys a little bit about, okay? So welcome. This is called Code Level Threat Analysis, which is not an exceptionally sexy title. We couldn't really find a very appropriate title, actually, for this. This is kind of a working title. If you guys have suggestions at the end, I'd love to hear them. But bear with me. It's more about the concept. Okay, and it's about speaking to developers at a developer level. Okay, so a little bit about myself. My name is Sethi. I work at Security Compass. I'm supposed to be here with my colleague Saba. Saba is stuck on a small Caribbean island. Poor guy. So I'm here doing the talk by myself. Yeah, that's going to be on video, so that's good. So I do a lot of training and source code review, yada, yada, yada. I've done the helping develop and train the SANS class for secure coding and spoken at a few conferences, written articles. For me, two main areas of my interest are, and it's really around Java security, that's my kind of core competency, are around secure design, especially design patterns, and I'm going to talk a little bit about how that applies here, and aspect-oriented programming. So if some of you guys may have seen the talks we did at RSA or ShmooCon or around that. I'm not going to talk about that today, but if you guys are interested later, you can kind of reach me outside, and I have some interesting kind of proof of concepts around that. But enough about that. Okay, what is threat modeling? Let's ignore what's on the slide for a second. And again, open question to the audience. What is threat modeling? How many people do threat modeling? Okay. How many of you guys find it useful? Okay, most of the people who do it find it useful. So what is it?
It's a way of looking at a system from an attacker's point of view to determine what threats apply to the system and dip those against what has been remediated, what has not been remediated. If it's not remediated, or vulnerabilities that need to be fixed, or maybe accepted vulnerabilities.
That is an excellent response. This is a way of looking at your application like an attacker, right? There's been a lot of emphasis around that. In the blogosphere, there's been some talk about how that's a load of crap, that you can't really expect developers to look at an application like an attacker. I'm not going to get into any kind of political, religious debate. What I am going to say is that threat modeling has its place, right? It's a holistic view. So let's take a closer look. This is from the Owasp site. Okay, this is, if you go under threat modeling, this is what you're going to see. This is a output of a threat model. Okay, we call it an attack tree. I'm not sure the attack vectors and threats, those are the right terms here. Again, work with me. What we're saying here is we have some particular thing that can happen. So an attacker may be able to view other people's messages. That makes sense in that application, whatever application it is, right? So how can they do it? Well, we have a number of different ways that they can do it. A user might forget to sign off, and somebody can steal his session. Maybe there's some SQL injection possible. Maybe authorization fails somewhere. Maybe there's problems with the browser cache, and messages get stored, right? So these are all different ways that this scenario of attacker being able to read other users' messages, or misuse case, can happen. So what we get out of this is we get a list of countermeasures, right? So let's look at the countermeasures. Implement data validation. Okay? If you go to a developer and you say implement data validation, what kind of response would you get? Sorry? Implement data, that's it.
Stairs.
Blank stares, that's pretty much what you get. Okay, thanks, bye. So implement data validation is one of the things that can be done. And that's good from a high level, right? Implement authorization checks, implement anti-caching HTTP headers, use SSL. Okay, for these last two, if you go to a typical developer in an enterprise application, you say, we need to do these. What do you think he's going to say or she's going to say? The last two. They're a developer.
Not my problem.
Not my problem.
I'm not an employer.
I'm not, well, not an employer, or sorry, did you say deployer?
Deployer.
Yeah, I'm not, I thought you said employer, that was deployer. I'm not a deployer, I don't work with the infrastructure part of it, I work with the code. So threat modeling is really good in its current state for a few things. It's great for penetration testing. As a penetration tester, you get this holistic view of the web application or whatever application, and you look at all the points that you can attack at, right? If you look at the Microsoft methodology for threat modeling, you define individual components as things like client, web server, application server, database server. These are all very high-level components. They're architectural components. And we can say, okay, looking at this, one of the first things I do is run some kind of scanning tool to see if their patches are up to date, right? As an attacker, these are things that I would do. I'd check their policy, their passwords, see if I can break in with authentication. A lot of different things that you can do as an attacker, right? So it's a very useful tool for that. It's in-depth and it's rigorous, right? How long does it take to do a typical threat model? You guys who have done it before. One that you've done, how long did it take?
Anywhere from a week to 2 weeks, depending on the size of the application.
Okay. Week to 2 weeks, depending on the size of application. Very good estimate. How many of you guys are developers? All right, if you went to your business owners and you asked for a week to 2 weeks extra to do a threat model, what kind of exuberant response would you get? Would you get people saying, yes, I have a week, 2 weeks spare, here you are, run with it? What would you get? What kind of response? Get out of my office. We already have a time to market problem, right? So this is where threat modeling becomes difficult. It's rigorous, yet it's time consuming. So a lot of times people just don't do threat modeling. There's an offensive emphasis, okay? Countermeasures are only reactions to attacks, which is good, right? Because we want to do things in relation to the real risk. We don't want to talk about theoretical vulnerabilities. We want to talk about what can actually attack us in the real world. So that's where the word threat comes in, threat model. And this is a very important point. Threat modeling is really good at finding common weaknesses, okay, known weaknesses, the CWE. Distilling the CW, maybe to the OWASP top 10 or something like that, and saying, here's your application, here are the common weaknesses. But we don't really talk about business logic vulnerabilities, right? And I'm not going to go into a talk about what those are. I assume most of you guys are pretty well versed in that background. Okay, so threat modeling isn't there right now. So we've been doing threat modeling for a while. And at least at Security Compass, we decided we're going to branch out into a couple of different areas. One, we're going to make our models of applications more consistent with the way that developers understand design. Okay, we're coming in at the design level. We need to model it at a way that developers understand. Two, separate process. We need to look at a business process independent of the application representation, independent of how the application interacts with that process, and say what are the risks in this process to figure out business logic type vulnerabilities. Okay, I won't touch too much on that because I don't have enough time, but I will kind of just intro it at the end. So apart from being a typical consultant list of blocks, colorful blocks, this is a list of countermeasures. Countermeasures that you would see are common controls that you would see in web applications, right? We know this. This isn't necessarily a comprehensive list. I know somebody's going to put up their hand and say, hey, you're missing so-and-so and so. I understand. This is a good list, right, of known ways of fixing common vulnerabilities, right? So at the top, we have things that are session-related, and you can argue whether CSRF belongs there or not. I don't want to get in that argument right now. We have input and output areas, so validation, encoding, things of that nature. We have authorization. I don't have authentication as a single issue, and I'll talk about that later. And finally, we have just various other areas, right? Top-level error handling, that stack trace that gets sent to end users. Anti-automation controls like CAPTCHA, that kind of thing, right? These are all things that are security features. Okay, so who cares? Well, let's take a step into the design, to the developer's world. Anyone familiar with what this is? Anyone seen anything like this before? Okay, so what is that? Component diagram. A standard UML diagram, way of designing applications. So, sorry, let me ask again. How many of you guys are developers or have development backgrounds? Okay, how many of you guys have done UML or understand UML? Okay, almost all, right? This is a language that developers already understand. So if we take our application and we break, not all developers, but many developers understand. If we take our application and we divide it into components, right? Here, this is at a design pattern level. These are all individual design patterns from the core G2E patterns. And I'll get back to that later. We map it out. So either from a component level or from an object level, right? Objects are usually too granular to understand for somebody who's doing a source code review. It's going to take too long. But at the same time, we want to be more granular than application server. Because application server on its own is too big of an entity to really get granular on, right? We want to go into this depth. So things like intercepting filter, that's a design pattern, which is usually implemented with servlet filters. Front controller, some of these things really influenced how struts or Spring MVC framework are created, right? So let's take this, and let's take the list of common controls, and let's say, okay, now when I look at my application, where are those controls actually implemented inside the design of the application, right? So for instance, in my intercepting filter, that's where I'm doing a hard session timeout, right? So not an inactive session timeout, but an active session timeout, in case an attacker hijacks a session and keeps it open forever. I'm going to do that through servlet filter. Page level authorization. Who has access to specific JSP or servlet or ASP or whatever pages? I'm going to do that at the front controller. Business delegate. That's where I'm going to do functional level authorization, method level authorization. Storage cryptography. Okay? Storing passwords, storing confidential information, credit card data. I'm going to do that at the data access object level, right? So we're taking an application and we're documenting where all of these things go. Now, this is way too clunky and cumbersome of a notation as is. So what we've decided to do was do it this way. We go to each of the components and list out at those components what are the security features that they implement, right? And then what's important is understanding the nature of the application. We go back to the list of controls and say, you're missing these controls from the design inherently, right? So this design, for instance, doesn't have setting the secure cookie flag or HTTP only cookie flag. It doesn't prevent against session fixation. There's no specific control for it. It doesn't perform canonicalization before it does input validation. There's no event logging of security events in a specific security log. No hard session timeout. No logical resource mapping, which is when you, say, try to get a file and you give the physical name of the file as opposed to some logical name. Well, then someone, instead of putting the file name, they say .. // et/password, right? Your directory transversal type attacks. No anti-automation controls, so things like CAPTCHA, right? That's not in here. So we know already at a design level what's missing, okay? So a few notes on this. You usually need to create this from scratch. How many people in the applications you review, you have UML diagrams available to you? One. One and kind of a nod, so maybe 1.5 out of everyone here. Okay, so usually you don't have UML diagrams to work with from the start. So that becomes difficult if you're not the person who designed the application. But if you're a person who's doing a source code review of the application, well, all of a sudden, while you're doing the source code review, this is the perfect time. Because if you think about it, to really understand, and I'm not talking about just running a tool, but when you really do manual review, right, with the tool perhaps, you need to understand the internals of the application. You need to understand all of these individual components. So why not map it out as you're doing it? and document where you see security controls, right? You can also document compensating controls. Yeah, the secure cookie flag isn't set explicitly in any of those codes components, but it's being said in the web.xml, in the deployment descriptor, or we have a web app firewall that's handling our input validation, or whatever else, right? You document those in your diagram. Another note is that when you actually do this, real applications have way too many components and objects, usually, to document them all. So what we do is we take transactions, right? High-value transactions. And we consider authentication to be a transaction rather than one of those specific security controls, right? So it's a use case, a set of steps that happen that goes along the entire design of the application. And so we look at authentication and say, what are the components involved in authentication? We make sure we model those. Then we say, I don't know, money transfer, purchasing, some of the high-risk use cases, and we document those components. We may not be able to document everything, and we may miss things, but that's the nature of a source code review, right? You're always going to be doing a portion of it, okay? So you want to do at least at that level. And the point here is when you're modeling in UML, use a static structure, not a dynamic structure. How many people are familiar with sequence diagrams, collaboration diagrams in UML? Okay. Why might I say let's not use those? Those are pretty useful, right? If you think about it, it shows the data flow. How many people have seen those used in a real application? A couple of you? How many were there? How many different diagrams?
Oh, we would do features.
Okay, so you might see it for individual features, but for a typical large web application that doesn't have any documentation, to do all of those transactional flows is really, really time consuming, and it's not worth the effort. So realistically, we're looking here at static structures, right? We're looking to see where security controls are implemented, and less about when they're implemented. That's done when you actually do the review, okay? Okay, the other thing to remember is it documents design level controls, right? So something like an input validation routine or output encoding are design level controls. Things like resource closing, so closing your database connections, logging of confidential data, proper concurrency, these things, they're coding issues, right? You can't really capture them at that design level. So it's not intended to capture everything, but it is designed to capture the things that are important when you're designing the application. So how does it work? Well, we take whatever we can. If we have some documentation around patterns, design patterns that are used, we take those. If we have source code, we take that. We have documentation. If you actually are lucky enough to have an application that has documentation, great, take that too. Take use cases if they're documented. For a lot of you, this is probably these are the only two things you'll actually have when you're doing a source code review. So this is very important, right? The developer, the architects are the ones that can really speak to how the application is designed, right? So you can probably save a lot of time by talking to them as opposed to trying to figure everything out on your own. Okay, so you take all of that, you create your diagram, maybe while you're maybe these two create diagrams and assess applications actually done at the same time, right? So as you're doing the source code assessment, you're creating the diagrams and you're also revising the diagram as you go along. So you might have had initial assumptions. Developer told you one thing, oh yes, we do whitelist validation everywhere. Then when you actually look at the application, there's no whitelist validation. Okay, well, you need to update your diagram. Okay, and you keep revising it, right? And I could have put one of those cycle diagrams, but I think you guys get the point here. So this has pretty important implications, and this is one thing that I think is where we can really use it, is common design patterns. So this now gives us a tool to communicate security best practices and security measures at a design level using patterns, okay? So how many of you guys have done J2EE or Java development? All right, how many people have seen or heard of this book, Core J2EE Patterns? Okay, quite a few of you have, right? This is I'm not going to say Bible, but this is a very sacred text in the world of J2EE development, right? People have been using this for a very long time. The idea of intercepting filter. Before servlet filters were around, it was a core J2EE design pattern. session facade, data access object, right? If you've done source code review on large applications, you've probably seen some of these, especially in the J2E world. But I mean, you have this kind of concept in other development frameworks. It's not just Java, okay? So we can take this, and what we're actually doing, I'm going to be putting out a white paper with a couple of my colleagues, is reviewing each of these patterns to say, here's where people miss security a lot in the pattern level, and this is where is an ideal place to actually implement a security feature. So let me take an example. View helper. Okay, what is view helper? Well, this is from the book site. Okay, this is the UML diagram. You have a client, which is not necessarily an end user client, but something in your application. So front controller, application controller in your MVC framework, right? And what it does is it dispatches a view. It says, okay, now create something visual. But the view itself is abstracted from the output, all right? So you have something called a helper that outputs things into Java beans or custom tags, tag files, something like that, right? And then that is sent over to the presentation model, and the rest of the application continues. So this is the design. This is a design pattern. So what can we say about this? Well, we can say, this is where you need to put HTML encoding and JavaScript encoding, right? This is a best practice. It makes sense to put it within your tags, because that's where your output's going to come. And what's great about this is now portable. This is not about a single application anymore. This is about for anyone who uses this design pattern. Now they instantly know where in their application they need to implement, or at least they should implement, not necessarily need to, but should implement certain security controls, right? So now we can actually build a library of these things and dispense this as best practice advice to developers, even if they're not using struts or they're not using Spring or whatever individual framework. It's independent of that, right? So I'll take a bit of a case study here. Is anyone familiar with the vulnerability that Ryan Berg and Dennis Cruz at Ounce found in Spring's MVC? Anyone else? A few of you? Okay, so do you remember what it was, roughly? There's a couple. So one was around forms and parameters and forms.
Okay.
Anyone?
One was injecting to the control point in the framework to allow you to jump to other calls.
Yeah, so okay, so that's one. And that actually also applies to design patterns, but I won't talk about that one right now. There's another one.
Every form had every parameter.
Exactly. So what happened is you have a form that has a bunch of fields in it, and then the user sends parameters. And what it would do is it would auto-wire those parameters into the form, right? So the problem with this approach was that there were cases where developers had some sensitive data that's supposed to be stored only on the server side that was never sent by the client, or never intended to be sent by the client, in the form. And if the client just added an ampersand, credit card equals 1, 2, 3, or whatever, these parameters, they would actually be automatically put into the form. Well, guess what? That's a named design pattern strategy in the book, right? That is a design pattern, the context object design pattern, a specific strategy called well, I'll get to it in a second. Auto population strategy. Okay, this is what it looks like. You have a client, context factory, uses a protocol interface, in this case, HTTP servlet request, and it creates a context object, which holds a bunch of information that's going to be used elsewhere in the application. In that case, the context object is the form. Okay? So putting all this data into the form, and it's auto-populating it, meaning it's not checking against some list, and it's not doing any level of authorization. So what can we do about that? Well, now that we know that that is a design-level problem, we can say anyone who's using this, remember this, 2 pieces of advice, right? One is we want to see parameter-level authorization here. If somebody is going to transmit or submit parameters to our context, right, through this protocol interface, before it goes into the context, let's make sure that that particular user is allowed to do it, right? So we need to at least include some level of authorization, or we need to make sure that all of the parameters are allowed to be supplied by that user. So we can actually dispense advice this way, right? Again, in a way that's at a design level, that developers can understand intuitively by looking at it. Okay. Any questions on that? All right, before I do this, let me ask you guys, open question. First of all, anyone see problems with this entire approach using this framework level threat analysis, design level threat analysis? See issues why you wouldn't use it in real life? Very time consuming, okay? Excellent point. Adds a lot of time to the process.
A lot of the times, the people you're communicating with are only looking at one piece of the application and don't even have access to the original UML design specs.
Right. So in those cases, when you're doing that, so when you're actually doing for us, most cases is going to be at a source code review level. If you're just reviewing a component, then you do that analysis on the component, right? And you would point to say that these are assumptions I made, possibly, that no other component is doing this, right? What about benefits? Anyone see benefits to doing this? No one? No reason to do this? Defense in depth, okay. Another way to add security. Raising awareness. I'll talk about some specific, both defenses or benefits and drawbacks, okay? Why is it a good thing? Well, you document security features of an application, right? We actually say which components in the application are responsible for doing those security features. It's documented. Yes, it's more documentation, but that becomes important as the application evolves, right? It speaks to design development people at a language they understand. It's not some security language, and it's not involving a whole bunch of components that are outside of their scope. It's stuff that they understand that they work with, right? And you're getting to the actual component or even object class level, right? And perhaps more importantly, once it's created, right, it can be taken by the developers and extended, right? They have this. And now when they design new features in the applications or when new attacks come out, they can look at the application design and say, hey, we have input validation over here. Let's review this input validation component and see if we're actually protected against this attack. Or we're going to add a new interface into the application. What components do we have to build into it from a security perspective, right? You actually have it documented at a design level, and developers can maintain it as the code base changes. Security features are there for a quick reference, right? So one of the more important things is it's a cost saver. If you are a person who does code reviews, you do this while you're doing the code review, right? Then there's not as much additional time because you need to do this all in your head anyway. So this is documenting it, right? Then the next time you do a code review, you don't waste time, or as much time at least, on the components that you know are not relevant to security, right? You're actually saying these are the components that are relevant to security. And yes, there are other things you need to look for, like I said, synchronization, et cetera, but you can focus the initial time on the components that are most important to you as a source code reviewer, right? So this actually becomes a time-saving mechanism as the application evolves. So drawbacks, you need to really understand the code, really understand it, right? Like you need to look at that source code, or you need to have a very deep understanding of the design. This is not something that you can just whip up, right? And it's not intended to be. We already have that, right? We have threat modeling. This is really for the focused, in-depth review. It's more time-consuming. It's actually about twice as time-consuming as a traditional threat model, meaning realistically, you need to do this while you're doing source code review. If you try and do it on your own, you're going to get shot down, right? No one's going to give you the time to do it. But unless you have a very kind of proactive security company and they understand the benefit here. But while you're doing source code review is the best time to actually look at this. And you're going to spend more time meeting with clients to understand things. Okay, that's whether clients means you're an external consultant, or whether it means you're the security person or the developer talking to, say, the business people in the company. Whatever it is, there's going to be some more time spent on that. There's no tool support for it, right? I mean, there's UML diagrams, but there's no Microsoft analysis. The Microsoft threat modeling tool doesn't really go to this level, right? That's a drawback. The other thing to keep in mind is that this is a very narrow view of security. It doesn't talk about holistic security on purpose, right? You will not catch patch management or poorly configured SSL or anything like that at this level. That has to be done separately, right? But usually that's how it's being done anyway within a company.
Quick question.
Sure.
You said there is no tools support for it.
Yes.
It being
Being this design level threat analysis. So there is UML tools, but this entire process doesn't have a tool.
I can say that if I identify a clear pattern here,
Mhm.
there are tools out there that can help me enforce, at least from my doctrine that we have tools in which you can define rules
Yes.
that will help me enforce the use of those patterns.
So in the source code review part of it, you're talking about
Both development and source code is
both the what, sorry?
both development time, for developer to use it and the source code review time as a review.
Right, so but I mean, yes, you have rules that you can apply on the code itself that actually do the analysis on the design. That's not something where we have tools in, but there are, UML checkers, or you can check for certain constraints and that kind of thing. But realistically, to do this process right now, it's not there.
Talking just like a process as a design,
Yes.
if I have a picture out there, you don't have a tool that will say, okay,
You have tools that will help you
okay.
to find the security features, which is obviously very important, but that again gets into source code review, which is not what I'm talking about here, not doing source code review itself. So we need to remember both that this, or rather we need to remember that this is a very narrow view, right? And this is not supposed to, it's not supposed to be in place of things like penetration testing or anything like that.
Just to make it clear for me, are you saying we should use this more fine-grained model, both for the threat modeling part and for the countermeasure, assigning countermeasures, or only for countermeasures?
So what I'm saying is this is actually independent of the threat modeling component that most organizations already do. In fact, I'm not even sure this should be called threat modeling. That's why I said this should really be done as part of source code review.
So from the threat modeling, we get the list of the countermeasures we need, and then we assign them on this more fine-grained module.
Yeah, you could certainly do it that way, but then it depends on what level of threat modeling you actually do and how accurate that threat modeling is, and if you really get a sufficient list of countermeasures from that threat modeling. Yeah. But my point is we can also document common libraries without even doing regular threat modeling. We can have libraries of countermeasures that apply to specific types of applications, right? Enterprise J2EE app, here's the list of countermeasures that generally apply. You take out the ones that don't apply, and then you say, okay, now where is this actually implemented in my application, right? I'm going to talk just briefly about this business logic part of it. One thing that we've also seen is that in that whole area, right, the whole thing that we talked about, that didn't really address business logic vulnerabilities, right? Like price parameter changing, for instance, parameter manipulation. That's not something that you can just figure out from that level of threat analysis. So what we want to do is, again, I'll talk about how you can do this practically. But you take a business process. So here we have an insurance company, okay? So you have a customer who calls into the company. Customer asks for a quote. Phone rep enters this data into the quote system. Policy rep retrieves that from a queue. Policy rep determines the quote, what dollar amount we should give them according to some tables. Policy rep actually creates the quote, and then a manager signs off that it's correct. And that's mailed to the customer, and it's legally binding. Okay. So what we say to do is take this, right, business process independent of the application itself, just a high-level business process. And a lot of times, people have already documented this kind of thing for SOCs, right, SOCs narratives, swim lane narratives, that kind of thing. Take the business process and look at each step and say, if I was an attacker motivated to do each of these things, or any of these things, right, how would I do it at that step in the business process? So for instance, we have the manager signs off that the quote is correct. Well, suppose I want to make money by getting a lower quote, or more likely, I want to cause harm to the organization. I want them to suffer dollar losses, right? Or I want to diminish their capacity to make decisions. I want to give them bad data so that they, in the future, they're not making the right decisions because they're a competitor of mine. Well, what I can do is policy rep bypasses manager sign-off, right? I can say, let's bypass this manager sign-off so that the policy rep creates this quote that's completely out of the ballpark, it's completely wrong, right? Like thousands of dollars less than it should be. And because it's legally binding, as soon as it's mailed to the customer, right, you basically lose money at that point if they accept that quote, right? So this is a business logic potential attack. And we can take that, and when we do the source code review or penetration testing, we can say, okay, this is something that I need to look for in the use cases, right? Because we're looking at it from a business logic standpoint. So this finds things that are only specific to the business process. And in how to implement it, has anyone heard of the facilitated risk assessment process? FRAP? It's basically taking the idea of threat analysis, risk analysis. It's supposed to take several days, and you do it in like a couple of hours. So you get a whole bunch of people in a room, right? You get the developers, security people, business people, throw them in a room, and just do this on like the top 10 business processes, top 10 highest risk business processes. Come up with an output, and you use that when you're doing your review. Okay? Any questions on that? I don't want to go into too much more detail about that, but any questions? Okay, well, that's pretty much the presentation. If there's any more questions about anything I talked about, let me know. I'm going to be around, so you can feel free to just reach out to me. All right, thanks, guys.